Well, thanks, Kevin. And yeah, it's a privilege to have both the Tretheweys. I've gotten to know both of them over the years, and certainly they're both very well grounded in hydronics. And we're going to keep this as a conversational webinar. I'm going to ask a few questions and then turn them loose with the answers. And as we go through, certainly as you have questions, feel free to submit them as Kevin has instructed. I'm going to start off with this because we were talking the other day, and Rich is very passionate about this, as I am as well. Why do we want to use water to move heating and cooling through buildings rather than air? So, Rich, I'm going to bring up this slide and let you elaborate on it a bit here.
Well, I've been a wethead for a long time. The only reason we really love you, John, is because you can say our last name correctly. By the way, just we're often mispronounced. Um, but I've been a wethead for a long time. The power of water is something that is undersold, and this slide or versions of it have been so helpful. If you put a BTU of energy into water, a BTU sticks. One BTU sticks, and John, your slide there with specific gravity. If you put the same BTU into air, 80% of it doesn't stick. It's a minor. We've taken the worst transfer medium ever invented, arguably, and using it to deliver the last mile in buildings everywhere. And so, we'll talk today, I'm sure, about the whole mini split market and how rebates have driven that market crazy. But we have to find a way to come back to our roots for the last mile delivery, particularly in existing buildings that are perfectly insulated, and we could use water as that medium. And so, I've always spent a long time trying to convince people. Again, you didn't have a solution for cooling back then. But now you can do hydro air and do all kinds of things with a chiller and air to water heat pump, which we're talking about today. So that's the only thing. But that bottom slide is also what we do to buildings, cutting the buildings to smithereens and taking every bit of the structure out. you know, People make fun of plumbers, but the HVAC guys can be even worse because the ducts are so big. And all we have to do is soffits and stuff like that. So I won't go too long, but just today and in everything we're talking about, we're talking about efficiencies with all these heat pumps, and then we put it into air. So why couldn't we have that last mile be the most efficient way to deliver energy around a building and do so?
Yeah,
So
and we're we're seeing hydronics being rediscovered. I think
Mhm.
what we've probably seen over the years is that many people think of hydronics as an old dusty boiler. Excuse me, and they think it's an antiquated approach, and really modern hydronics is anything but that. So, Rich,
Ross, you were raised on water. You were raised on hydronic. You were raised.
I was. I learned from both of you a lot,
Yeah,
from my
yeah,
being a baby all the way through. But yeah, I think, I'd echo the same sentiment, like hydronics, that's what I was raised on, and that's what I firmly believe in. And I think, this slide tells you a lot here, right? The amount of energy you can
yeah.
transfer through a 14 by 8 duct is equivalent to a
Right,
3/4 inch pipe. What would you
right.
rather have for distribution of energy through a building? And then, water is 3,500 times, can hold that much more heat than air. So it's like, I got something that can hold heat way better, and I can transport it with way less energy with much smaller distribution piping than
Right,
ductwork. It wins
right.
all day on all of that.
Yeah.
So yeah, that's
yeah.
With the
So yeah, I'm going
yeah,
back. Rich, you and I have been in this at least 40 years. I think I stopped counting after 40 years,
I
and
know.
we've
You
watched
look
this
good. You look
market,
good though, John. You look good.
as do you. Um, So, we've watched a lot of innovative stuff over the years. We've watched PEX tubing come into market, Micron boilers, microprocessor controllers. So, what are your thoughts on product innovation? What products do you think have had the biggest impact on keeping hydronics a relevant and modern technology?
Well, I started that rep business back in '89, and we pioneered all that stuff, meaning it was radiant flow heating. We were the first Stadler Vega rep, and then And then Viessmann boiler, the first, the ModCon boiler changed everything. It used to be 78% efficient. All of a sudden we got to 95. That quantum leap was sort of crazy innovation. It was just nutty. And then even the small mini duct systems, that use hydroair. So all kinds of stuff. I think, I think the innovation that has to come now is really an idea of a magic box outside, one magic box outside with all the refrigerant, and you keep it outside, and you come in and you do every single function inside the building. Just as Radiant changed the game for hydronics, this air to water heat pump really has to be the next major innovation. And what we'll talk about today and going forward is how to make that thing repeatable, how to make it go in easily, how to make it be just like a replacement boiler would be, that or a furnace system. Have the box outside, and then come inside, and then you can get your domestic hot water, you can get your cooling and your heating, and then choose from an a la carte menu of how you deliver the last mile to the building. Radiant where it belongs in the great room or vaulted spaces, hydroair for chilled water upstairs for the air conditioning, and just find the right way. This nuttiness that we do now of putting miles and miles and miles of refrigerant piping through every building, or sticking these awful fake downspouts on every single building. I mean, we'll look back on this era, just like looking at Harvest Gold appliances or avocado, that this was the heat pump rebate era, where every single house has 25 fake downspouts, and it's just saying, yeah, vinyl. It's like saying, I gave up on being smart. I'm just gonna just run them on the outside of the house, like leaving abandoned cars in your driveway in Maine.
Yeah, yeah. We've done some calculations on heat loss on that exterior piping. And in some cases, you can lose 5,000, 6,000 BTUs per hour outside the building,
Become
before
a
you
snow
even.
melting system. It becomes a snow melting system for the roof.
Yeah. Hey, and I'm going to jump over to Ross for a minute. Now, Ross, licensed engineer, you've got your own company, T2 or TE2 Engineers, and you're dealing with a lot of clients, and I know you're dealing with hydronics. I'm just curious, what do you find as the motivators for your clients when they come to you, especially if they're looking for a hydronic-based solution? Do you find they've done their homework, or are they completely clueless and willing to, listen to what you're recommending for 'em?
Yeah, yeah, we see kind of a wide variety of clients come to us. Some of them that have done their homework are very educated and very in tune to, hydronics and, the HVAC industry, and they might request
Mm.
specifically air to water heat pumps, for the design. We have some clients that have no understanding of the HVAC industry and have no understanding of what the heck an air to water heat pump is, and they don't know really anything, and we're there to educate them on that. We have a slide deck that we use for that, which is which HVAC system is right for your project. And in that slide deck, we basically describe what are the pros and what are the cons of all the different HVAC systems that are out there, because they all have pros and they all have cons, right? There's no perfect,
Yeah, yeah.
system. And then, ultimately, a lot of the clients end up choosing air to water heat pumps for a variety of reasons. Some of them may be that they want to electrify their buildings and they want to have a system that's paired up with solar, and they want the solar system to generate the electricity that the heat pump uses and try to reduce their operating costs that way.
Well,
Some of them, want it for other reasons. They want radiant floor heating in their project, and they know mini splits or traditional VRF, units are not going to do that. So air to water becomes that. Sometimes in a retrofit strategy, we are doing a hybrid approach. We're leaving the gas boiler or the oil boiler in, and we're supplementing with the air to water. So the air to water covers the
Yep.
majority of the heating and some of the cooling, and then we have the oil boiler kick on when it needs to, when it gets really cold out.
yeah, makes a
Uh,
lot of sense, dual fuel.
Yep, dual fuel for sure. Some of them are tuned into refrigerants, and they don't want refrigerant in the building. So, obviously, a package air water heat pump is awesome for that. Sometimes we have clients that want redundancy. So they say, hey, if this outdoor unit goes down, am I still going to have heating or cooling in my building? And so sometimes there's an opportunity there with air to water being modular, where you can have
Yep.
two units banked together. one goes down, you still got the other one there, and it can provide heating or cooling to the whole building.
Yeah.
Yeah, so a bunch of reasons clients want the air to water or end up going with the air to water. Those are some of the major ones that we see.
So, oftentimes you talk to somebody with expertise in an area and, they're giving you all these different options. And oftentimes you turn around and say, well, if you were doing it, what would you do as the expert? So I'm going to ask Rich, if you were building a new house for your family, what kind of an HVAC system would you put in there?
Well, I actually just did a full gut rehab, so this is a timely question. Um, we did everything we had to do to put in radiant floor heating in the entire first floor with a dry system. We use that Mr. Peck's system, uses 3/8 tubing, so it's good flow rate. And then I did mini duct Unico everywhere else, separate zoning, and then a heat pump, principally, but also a boiler as a backup. So I wanted that redundancy, and I had a Viessmann combi boiler that could give me domestic. So using a heat pump, using my cooling, using multiple zones, and it's been spectacular. It's just, when you are comfortable, it's this very hard to describe to somebody, in Ross's great slide deck. I mean, which, by the way, that would be a really good seminar to do your slide deck, Ross, to talk about some of the advantages of all the different methods. But I have a heat pump and radiant, and using water through the system, and it's perfect.
Good. So you're practicing what you preach, and I
Yeah.
expect no less there. So, Ross, same question. Let's say you were going to build a new house for your family. What would you prefer to put in there?
Well, maybe a surprise to you, or maybe not. I probably would do something similar to what my dad just mentioned. I think an
It's
air
my
with
boy.
water paired up with the hydronic gradient. I think, but I would say that if budget wasn't an issue, I would actually go geothermal, and I would go water to water. If I
Mhm.
if I truly had no budget, let's say no budget, and let's say I could pick any system, I would go with a hydronic-based system, but I would try to remove the outdoor equipment altogether and just do a vertical closed loop borehole system or something to that effect, and go water to water, using hydronics in the building for my heating and cooling. Same kind of terminal distribution equipment we're talking about, with radiant and hydro air for sure would be the way I would go. But obviously, I have a limited budget, so I would go air to water because that's gonna be, I think, a far more effective strategy than
Yeah.
drilling, et cetera. Yeah.
Yeah, we've actually been doing some, comparisons, air to water versus geo, and both have their place in the market. Absolutely, both have their place. But one of the things we're finding, we call it a COP gap. Typically, the water to water is going to have a little bit higher COP, excuse me, on an annual basis compared to the air to water, but it has a higher cost to put the earth loop in. And when you look at return on investment, in many cases, the air to water does give you a better return on investment. And of course, these markets are skewed quite a bit by right now. We have a 30% federal income tax credit on geo that is going to change. And, if, as Justin and we were talking about it earlier, it's going to change kind of the approach that the geothermal heat pump market is going to have. And certainly the geo market is definitely going to survive there. But air to water is an up and coming technology. I think in terms of potential placement, depending on the density of the housing. If you're in a suburb area and you just have very small lots, geo it's not impossible, but it can be, I'll say, impractical or very expensive to do it. Whereas somebody that has rural acreage, and access to an excavator, they can do an earth loop, much lower cost. So um,
Agreed.
Real quick, John, I wanted to we got a question from the audience here, and this is something that I have not heard about until right now, but apparently the UK just announced a program to give installers air to water heat pumps to get them more comfortable recommending them. And he's asking if there's any similar in the US. Uh, I personally have not heard anything like that. I've always been a major proponent of this because I feel like getting more of these systems in the installer's hands will have the biggest impact on the marketplace. Just like Rich and Ross are talking about here, people are interested in what the experts are putting in their own home. And once the contractors are comfortable installing these systems, it will drop the cost because they're not afraid to be the guinea pig, if you will. And you can talk more confident about the operation of the system when you live with it. But Ross or Rich or John, do you guys have any news here? You heard of anything like this?
Oh, yeah. I I haven't heard that yet, but it's inevitable. I remember in '95, I think it was, Britain passed a law that said you had to put only in condensing boilers. Now, this Britain at that time was burning peat moss. It went from literally primitive to high tech, and then all of a sudden, and that became a multi-million boiler market in overnight by mandate. And but so and it changed their consumption because they didn't have any fuel of their own, and so they had to do it. The problem I see is education here in the United States. People that are establishing rebates don't really understand the real life of what we're talking about today, the power of water or any part of its relative efficiency. So we would need some pretty interesting advocacy by people to train the governing bodies for rebates and all the other stuff, and also like you say, Justin, we need to make it repeatable. We have to make it be that everybody wants this magic box outside, this air to water heat pump, this one device that can do everything. But it isn't repeatable enough yet, and the price premium is a little too high currently. But we got to do something to change it. I don't know if I'll live long enough to get the government to mandate it like the British people seem to ask, but
Yeah. Well, we are seeing some rebate programs. I know Vermont, Massachusetts, New York have rebate programs. Yeah, for air to water.
Good.
Yeah, Efficiency Vermont and the Mass CEC both have very good rebates for air to water heat pumps. Yep, so that's a good start. And I know a lot of the manufacturers of air to water heat pumps that are in the US market are starting to donate their products to kind of prime the pump for certain projects. There's a Studio HBDC that's being built right now in Newton, Mass, which is going to be heated and cooled with an air to water heat pump as well. So it's starting to flood the market a little bit with these kind of donations, and that's definitely going to help. But I didn't know about the UK market, and that's interesting.
That was an interesting question. Chris, real quick, Rich, Chris took a little exception to your cars parked outside in Maine. He's from Maine, apparently. It didn't go unnoticed.
There was just one street that I was on in Maine that everybody had cars. It was not your house, not near you, Chris, at all.
It wasn't Chris's tree. Yeah.
Yeah, I just thought it was funny. But real quick, he asked another really good question about how does the perfect hydronic system dehumidify? And I feel like this is a pretty common misconception of hydronic-based systems. Ross, do you want to hit this?
Yeah. Yeah, absolutely. Yeah. So I think a lot of people, you're right, have a misconception about hydronics and not being able to dehumidify at all. And so let's just go through the basics, right? So you're running chilled water in a hydronic system that could be at 42, 45 degrees, something like that. That's running through a hydronic coil in an air handler. When that happens, the byproduct of that is that you cool the air and you also dehumidify that air because the chill water temperature is below the dew point of the air that's going across it. So a very, very basic, principle here that if I run chill water through a coil that's cold and I run hot, humid air across that coil, of course, I'm going to cool that air and dehumidify that air. And that the sensible heat ratio, effectively, like how much of that cooling capacity drops the temperature versus how much of it drops the moisture, is something that we can actually play with and have way more control over in a chilled water approach. And so the way I look at it is that with chilled water running at 42 degrees in a coil, let's say, I can throttle the fan speed down. And by doing so, I'm going to actually lower my sensible heat ratio. So meaning that in a traditional, let's say, VRF mini split system, let's say a hyperheat unit, right? that unit might have a sensible heat ratio of 0.93. That means that 93% of the total cooling capacity drops the temperature, but only 7% of it drops the moisture or dehumidifies, which is why they do a really good job of meeting set point, but you have a 60% or 65% humid environment when those things run. And so the advantage with chill water using hydronics and air-to-water heat pumps in this example is that I can now take that sensible heat ratio from 0.93 and drop it down to 0.7, 0.6, even 0.5. So I could throttle that fan speed down instead of going 400 CFM a ton, or everyone says, oh, I got to live at 350 CFM a ton. I can now throttle that down and run at 200 CFM a ton or 150 CFM a ton. So what that means is that that air goes very, very low and slow across that coil. It dehumidifies like crazy. Water's dripping off that coil, dehumidifying amazingly. And then we have that nice, dry, dehumidified air being supplied back to the house.
Yeah. Excellent point here, Ross. And, you know, it's a good lead into the next question. I'll go back to Rich and this. One of the things that we've certainly lived through in previous years with hydronics is a client that gets excited about, let's say, floor heating, really excited, ready to sign the contract. And the question comes up, what do I do about cooling? And traditional boiler guys will say, well, I've got a buddy that does this, or, we don't do it. We don't want to get involved in it. So now that we've got heat pumps, both air to water and water to water geo, that are capable of producing chill water, how do you see what I'll call small scale chill water cooling developing in the market? Say residential scale chill water cooling.
Well, little residential 5-ton chillers have been being sold for a long time. They just weren't high enough quality. I mean, the this Enertech unit is built so beautifully. I mean, it's the kind of thing that you can put it out there and simply pipe it. I think all the poor hydronic contractors all had to learn how to do refrigerant because they were forced to do mini splits. There's a good established contractor base that would love to be able to just do it as a piping job, just do it with hydronics and, do hydro air for the chill water delivery, cooling delivery. There's tons of them, and we just have to educate them. We have to make it. I keep repeating myself, but it needs to be repeatable. Every installation has to have a way that it's not. Remember, John, in the early days of Radiant, every Radiant contractor was building a one-of-a-kind wall that only he could follow his logic. It was all, a million pumps and zone valves and all kinds of stuff that was his creation. And so we need to come back to a simpler way that just says, I've always dreamt of, you've seen these in Europe, John, the pre packaged piping system with PAW, literally you could just have a system, and so you'd walk in and it's not like somebody's new invention every single time, and have it snap these pieces together, and just make it be that the job that's done on Main Street looks no different on Elm Street, like you just have it be repeatable. And we have to get away from this sort of Wild West creativity of making one-of-a-kind walls in basements, just make it repeatable. I think it will do it. Yeah, I'm not sure that answered your exact question, but
well, take these systems more towards appliances, the concept of an appliance set. A consumer can understand what a refrigerator is and what a dishwasher is, and
right.
Many of them have a difficult time because they see a hydronic system as just hundreds of different components that some artisan is putting together, and
Right.
maybe only, the artisan may be the only person in the world that understands what that system is supposed to do when it's
Right.
working correctly.
Right.
But and then if that person isn't available for whatever reason, they moved on. How you end up with an orphan system, and
Well, we also, yeah.
that
Right.
has
We also,
plagued.
I'm sorry, Jack, go.
Yeah, no, that's plagued the industry for a while. Going back to the small scale chill water cooling, one of the things that I see is pipe insulation. As simple as it may sound, doing pipe insulation on chill water is critically important.
Critical, yep.
And many hydronic heating systems over the years, very few of them in North America really have good insulation, especially residential. systems. You might see it a bit more in commercial, but chill water cooling, even things like the volute of a circulator. I mean, we've seen projects with chill water cooling and even earth loop circulators that are, an earth loop by March in a northern climate is typically in the 30-degree range. So it's well below dew point. So there's condensation on the volute.
Sure.
And, looking to the market, one of the things I'd love to see more is insulation shells for things like small circulators or air
Yeah.
separate, or even isolation flanges for circulators that uh, one season with chill water cooling without the proper detailing, you can get a lot of oxidation and corrosion and rust stains and so forth. So we do need some of the more education how important that pipe insulation is with this chill water cooling.
Right.
On that note, John, a couple of things that we've done in recent projects with air to water heat pumps with chill water piping, the clamshell jackets and some of the manufacturers for some of the circulator pumps, they have those insulation jackets now that we can install. So that's a tremendous jump there. The pre-insulated PEX lines, which I know you're very familiar with, those are great because I can get a 50-foot, 100-foot roll of pre-insulated PEX and just run it out. It's no different than running refrigerant piping at that point, but it's PEX based. And then the valve wrap kits. There's these manufacturers that make these valve wrap kits. So basically, if you have an isolation valve, there's no real good way to protect that from sweating in a chill water arrangement. But now with valve wrap kits, it's basically just as it sounds. It's a wrap that velcros and wraps right around the valve, and it prevents it from sweating. And that has been really a game changer for some of those valves that looked great day one, but then year one or two later, it's it's got a bunch of corrosion and rusting or whatever forming on the outside of it. So
Yeah, yeah. Even things like hardware and so forth after a year or so. And Justin, I think you were telling me about a pretty unique solution there, involving Vaseline. You want to jump in on that?
Well, yeah, so I do a lot of hydronics training, and I mean, I will say in today's world, chilled water cooling is definitely getting easier. I definitely am, motivated to do what we can on our side of this to further that development. But things like insulated volute pumps and, but having a few install techniques to help goes a long, long ways. And, it's not the valve that actually rusts and looks terrible. It's the um, plated handle and the nut on the ball valve. And in most cases, ball valves, you're not opening and closing them constantly. It's also the pump, the bolts that hold the pump into the volute are generally not stainless steel. They're plated. And so by making a few of those changes where you just get in the habit of removing all the ball valve handles, serves two purposes. One, they don't rust and look terrible. And two, you keep people that don't know what they're doing from closing valves when the contractor's not there. But things there's always some level of exposed metal components that you are difficult to deal with, and bleeder screws on pump heads and things like that. Uh, so when I was on the contractor side, I used Vaseline, and on those exposed metal components, and I'm not slathering it on there, but a little bit of Vaseline on those small little components will keep the condensation from forming, and keep it from looking terrible, 2 years down the road.
Yeah. Yeah, that's I thought that was a great tip.
Mhm.
Yeah.
It's an easy one.
Sure.
It's good
Yeah,
for dyno crash too.
One of the things that I've heard in dealing with people over the years, there are people that say heat pump is completely sufficient, even in a really cold climate, and referring to air source heat pumps now, be it air to water, air to air heat pumps. And they are adamantly against any type of backup system. Well, I suppose they would accept an electric resistance backup, but they're definitely against any type of fossil fuel backup. And I disagree with that. I think, Rich, you were talking about this earlier. Um, we've done some modeling, and we're finding even in cold climates, upstate New York climates, that we can do upwards of 90% of the seasonal space heating energy from an air to water heat pump, and the balance of it would go to some type of auxiliary. So I tend to think that that initial market with air to water heat pumps is going to be largely a retrofit market where we're going to have existing hydronic systems with boilers.
Yep.
And people are going to want to put heat pumps in for various reasons. Some people want to reduce their carbon footprint. Other people are going to take advantage of, rebate structures and so forth. But let's talk a little bit more about dual fuel. And I know you said in your own house that you would do a dual fuel, and I believe Ross did as well.
Yep.
What do you see as the strong points of a dual fuel system where a boiler and a heat pump are present?
Don't tell anybody this, but I'm afraid that we'll have enough electricity on design days with everybody. We got an ancient grid, a lot of places. I don't hate having a backup boiler for design conditions. And I think most people don't. And, the minute that some of these houses freeze up, if we do have an interruption of power, um, that or not enough power, I think a lot of those people will be asking for the same people who gave the rebate money, to help them pay for the frozen house. There's something reassuring. This move to get rid of all fossil fuels, I think, is naive. I think I'd love to be green as anybody, but it's just something reassuring about having the power you need when you need it on design conditions. So
Structure grid just does not capable of even handle. So it's not even a reality that we could, it just as a whole. I mean, this is why we've worked really hard to make a few of our hydronic units dual fuel capable and
Yep.
onboard, controls and stuff to control a boiler. But I couldn't agree more. I think dual fuel is definitely a very uh, a very good option for a lot of areas.
One of the concepts that you read about a lot, you'll see this word, and over the years, you see various words being kind of put into PR pieces and so forth. And one of the words that seems pretty popular these days is resiliency or resilient design.
Mhm.
And it makes sense. The idea that if you have a system and it's working fine, but you get this extraordinary weather event, you get a big hurricane, let's say, or whatever that cuts power for 2 days, 3 days. How do you keep that system going? And one of the strong points of a fossil fuel boiler system, be it an oil burner or gas burner, they run on very small amounts of electrical power compared to a heat pump. So, for example, we could set up an oil-fired cast iron boiler that may need maybe 400 watts to run that burner. And let's say we've got 3 or 4 circulators and there may be 60 watts apiece. We're our electrical load is so low that we could run our entire hydronic fossil fuel system on a small tabletop generator, I call them, little Honda generator or Harbor Freight generator. Whereas if we wanted to run a heat pump, especially if we have electric resistance heat involved, we need a much larger generator, something like a Generac, 18 kW, 20 kW generator. So one of the things we've been talking about a little is, can a contractor, when they put in a heat pump as the primary heat source, could they rewire the boiler in such a way that a transfer switch could be used to just bring the boiler and the zone circulators or zone valves, anything that's necessary to run that fossil fuel based hydronic system, and simply plug in a generator, a small generator. And as long as you got gas in the generator, you've got heat. So that's a strong point of a dual fuel.
Yeah,
Nick,
resiliency. For resiliency reasons, absolutely. For risk mitigation reasons, absolutely. I think the other point here would be for energy inflation reasons, right? We don't know where the cost of electricity is going to go.
Amen.
And the cost of electricity from 2016 to now has gone up from national averages all the way up to 17 cents, I think, last time I checked. Here in Massachusetts, we're at 31 cents a kilowatt hour currently. It was 16 cents a kilowatt hour about 6 years ago. So we've doubled our cost of electricity in the last basically 6 years. So, who knows where that goes? A lot of people have a hypothesis that it's going to keep going up, and I probably agree with them on that. But my point is that, hey, if the cost of, let's say, natural gas or oil or propane holds steady or goes down relative to the cost of electricity, now you have, the ability to do energy arbitrage, right? Where we can actually pick and choose what is our way to heat the building. Are we heating with gas? Are we heating with the heat pump? What's more effective? So having that dual fuel hybrid system allows us the ability to play, basically play with those levers to make that.
And having water as the delivery method.
Correct.
Yeah, it stays the same.
And to Ross's point, I've seen some controls out of Europe that you actually input the cost of the fossil
Yep.
fuel energy,
Yep.
the cost of electricity, and
Yep.
they will monitor outdoor temperature, and they need to have some information on the COP of the heat pump, but they will do the calculation and say, all right, at this point, you're going to provide heat at a lower cost using the boiler compared to the heat pump. And another spinoff on this dual fuel, and this I think is a really a strong potential growth area for hydronics going forward. Time of use electrical rates. We're doing some work with some people up in Maine now. On peak electricity is 44 cents a kilowatt hour. Off peak is 7 cents a kilowatt hour. So that's a tremendous rate differential. Imagine I used to compare. Yeah, imagine you could go to a gas station at 2:00 in the morning and buy gas for 60 cents a gallon or 50 cents a gallon. What would the line look like at the gas station?
Right.
So
Right.
with hydronics and to Rich's point, with the power of water, the ability of water to store heat, we combine an air-to-water heat pump with thermal storage, especially as we're getting into these refrigerants now that allow us higher temperatures, 150, 160, potentially even higher than that. So we've got a heat pump, we've got thermal storage, and we've got a hydronic distribution system that we could operate on outdoor reset. So we could run relatively low supply water temperatures, especially with radiant systems. I think about the potential, and to the point where these electric utilities are feeling the crunch, the limitations of their grids. They're going to get more creative with these time of use rate structures, and hydronics is really an ideal technology to leverage that.
I have an ongoing dream that we'll have BTU batteries in our house, and meaning a pressure. There was a product we played with years ago, John, called Wear It, and it was this pressureless polyethylene tank, super insulated, and it had coils on the top, and you stored energy, and so you could come off your shower drain, you could come off anything, and then you could store energy there. You could get your potable water back out of it. Sort of, it's like a Turbomax, and we imported them from Europe, but the bulk cost of importing a tank that big was just crazy. But this BTU battery, there's so much scale, and then again, once you have that BTU battery, you can use water as that last mile and deliver it all over the place. And I hope that's something that might come in what's left of my career. But so, yeah. The other point I wanted to talk about to build this market is we have to assume that all the hydronic guys have almost they're not there waiting to go back. We have to find the next generation of contractors. Running pipe now is simplified with ProPress. I mean, nobody has to solder anymore. The piping process is easier, right? The every bit of it is repeatable. So it isn't like we're going to find, and so what we really need is people to get your book, John, Modern Hydronics, and read it, and learn how to just what pipe size do you need? The materials are so simple. PEX has changed everything. It isn't like we have to find the guys that used to do radiant to do it, because every bit of this stuff could be trained to anybody. We have to find the next generation of people that are joining this industry and train them to do it, like we've done all through the years with all the products.
Absolutely. And it's looking at traditional hydronic contractors, plumbing and heating contractors that are very comfortable around boilers and piping, but some of them just have little, if any, experience with refrigeration systems. And one of the the concerns I have is as we go forward with more and more heat pumps in the market, is that we're going to have contractors that can, for example, set a monoblock heat pump and get the system in and get it operating. But if there's any problem with the refrigeration side of that heat pump, an expansion valve, anything, a leak, they need some basic training. I call it refrigeration 101, how to identify, how to capture a charge of refrigerant, recover it, how to pressure test the system, how to braze, and so forth. So they're going to need some basic refrigeration training, because one of the things we don't want to see happen, we don't want to see these orphan systems. And again, we've probably been in this industry long enough to see, as solar thermal came into its prime day, there were a lot of people putting solar thermal systems in. And then as the market kind of moved away from solar thermal, these systems became abandoned. You can find people that would work on it. Same thing with biomass boilers. So, so Rich, if you're talking to a contractor and they're showing some interest, let's say in air to water heat pumps, what kind of advice would you give them as far as training? Let's say they know the Hydronics 101 part. They know how to size a pipe, how to pick a circulator. What else would you suggest that they learn to deal with?
I don't necessarily agree with you fully on that they have to learn refrigeration, because if you can get this thing, it already comes pre-charged. It already comes factory tested. It's, you'd have to do something to it to make it, and you can always find a service tech that understands refrigeration. What we need is the hundreds and hundreds and hundreds of these to be installed and have them be piped correctly on the hydronic side and run them. Meaning, if we're going to also ask them to buy the capture machine and the pressure the vacuum pumps and all the other stuff, I'm not sure they have to. There's techs that are available that you can do on a you can hire. So I'm not sure we have to. The beauty of this system is you don't have to be a refrigeration tech to make it run. The refrigeration is already done for you. It's pre-charged. Heaven help us with the other methods, because you have to add a trim charge. Nobody ever adds too much refrigerant. They throw some refrigerant in. That's causing more trouble than anything. I think the beauty of this is that the Enertech or any of the air to water heat pumps are really appliances. They're already pre-charged appliances that you just have to fundamentally plug in, but with piping.
Yeah, the monoblock systems. And, and I think they probably are going to dominate. There are some split system air to water products out there. But at this point, at least in the North American market, just looking at what products are available, it looks like the monoblock configurations, to your point, that are pre-charged with refrigerant are certainly going to be the majority of the market at this point. So
how many more refrigerant changes are we going to have in this country in what's left of our careers? How many more changes of refrigerant? Silly.
That's a great segue, because we had a guy ask a question about when we're going to get R290.
There you go. Take off on that.
And I would be in full support of us using R290. You're going to have to talk to your local lawmakers on those.
There are thousands of air to water heat pumps running on R290. Just so everybody knows, R290 is propane. And propane is an excellent refrigerant. It's not the same propane compound that is used to combust. It doesn't have the mercaptan in it, so it's odorless. But refrigeration wise, it's really good refrigerant. Obviously, it's a flammable product, so it falls under an A3. I think it is A3 category refrigerants. But the European market, there are thousands of units from major manufacturers. We're actually working on a demo project right now with an R290 heat pump. I think it's going to happen. I think it's a matter of getting ASHRAE, UL, EPA, maybe everybody on the same page. I think it's inevitable. It'll probably be driven. My prediction that we're going to see California go with it initially, and it'll be driven from an environmental standpoint. And I think once that happens, that the rest of the country will go there. But that looks to be a really promising refrigerant from two big standpoints. One, it really low global warming potential numbers. It's like 3, where I think R32 is around 700, something in that range.
Yeah, I got it right here. 675 for R32 and 466 for R454B.
Yep.
Yep.
So,
Compared to CO2, I'm sorry, compared to propane R290, which is a GWP of 3.
yeah. So real low global warming, and these heat pumps can do about 170-degree water temperature. So potential for these higher temperatures. And one of the things that, I caution people on, oftentimes we'll get people that ask, can I use an air to water heat pump with a baseboard system? And, just to be cautious, I'll say it depends. But with outdoor reset, there's many times when that baseboard could be running well within the operating range of, let's say, R454B or R32, even R410A, even though that is out of production at this point. So we don't want to dismiss a baseboard system simply because we think it needs 180, and it might at design load, but the vast majority of the time, you're not at design load. And Rich, you and I, we were talking about this the other day, that it's like 2.5% of the hours in a year when you're at design load.
14 hours
So
a year.
yeah, so outdoor reset really brings those water temperatures down, and that's going to improve the performance of that heat pump.
Yeah, part load for sure. You don't need the full design temp, and so that's where air to water right now can plug in. But that's what the A2L refrigerants. I'm frustrated that we went from, the A1s with R410A to R32 and 454B, and not go all the way to R290. I think this is just like a sidestep, where it's like I think all roads lead to R290. Air to water heat pumps from a heat pump perspective on our buildings. It's more thermodynamic efficiency than the traditional R32s. It's a natural refrigerant. It's lower GWP. I just don't. The only downside I can really see is that it's volatile, that it's inflammable.
Volatile, volatile and odorless. Wait a minute. So volatile
Correct.
and odorless. Hello?
Yeah.
Yeah, correct. Yeah, but the thing is, it's a self-contained package monoblock unit, so you don't need to have any
Good.
brazing, any
Yes.
torching. You don't have to have
Yeah.
anything. But there's education there for the
You're
contractor.
not contending 290 for use as the refrigerant to line set installations, conventional.
No,
No.
I don't see that.
Thank you. Thank you.
Maybe with
No, we're talking about split systems. We're talking about package monoblock systems.
yeah.
Thank you.
And when you look at those monoblocks that are using 290 R290 in Europe, it's interesting. The air separator for the system, I'll call it the spiral vent concept. That's actually within the heat pump. It's not inside the building. And so is pressure relief valve. So if there was a leak of R290 at a higher pressure into the water side of the system, the separation and the venting would occur outside. And if you look at the internal design of the heat pump, they are compartmentalizing the electrical. So it's isolated away from the piping that would have the R290 in it. So there are some design changes, but and I think everybody here thinks R290 is the likely future for the refrigerant. Hey guys, just
It's not like it's new. You know what I mean? The R290 propane refrigerators have been used on boats for many, many years.
Sure.
R290's used in, grocery stores already. We're seeing it also in Europe. There's thousands of R290 heat pumps installed in Europe. So nothing new here. It's just a little bit of a legislation thing to get through, I think, with the, what is it, 150 grams of max R290 is allowed in a package heat pump right now, I think is.
Number is
It's very small. It's under 200 grams.
Okay, I think it's 150 grams of total volume of R290 propane in a heat pump system.
so guys, I'm gonna wrap it up. I got a final question for both Rich and for Ross. And I'm start off, Ross. You've got an engineering company. I know you've got several engineers working with you right now. Let's say you're talking with an engineer student, they're graduating, and they might have an interest in energy. What kind of advice would you give them if they were showing some interest in the HVAC industry?
Yeah, I mean, we've got, what, 13 engineers, and a lot of them are young, right out of school, so, we're dealing with that daily. The way I think about it, if they're curious about the HVAC industry and heat pumps, et cetera, they obviously they gotta learn, right? And so the question is, how are they gonna learn? And so I think, we have so many good resources now that we never had before. We have obviously, YouTube and webinars and all of these resources at their disposal. So if they really wanna be that, curious learner to be able to, understand, how these systems work and kind of do the deeper dive, they've got it at their fingertips. They literally can start Google searching. They can buy your book. There's so many things, available to them. I also would mention that they should probably find a mentor, someone, either hopefully a company that they can work with, somebody that can mentor them and kind of teach them the ropes. And this is no different than an apprenticeship with a plumbing and heating contractor, just someone that can basically pass the torch on and can give them the answers that they need on some of the, on the fundamentals and the technical aspects of it, and even beyond that, life aspects and business aspects as well. So yeah, if they're curious about the industry, they can learn. They can go to industry events, webinars, et cetera, just like this, and then find a company and a mentor that will take them under their wing.
Hey, Russ, do you get your young engineers out in the field? They get their hands dirty. They get some screwdrivers and wrenches out, anything like that?
100%. One of the things we always talk about with all of our staff is that the best engineers are not the ones that are sitting behind the computer all day. The best engineers are the ones that understand the practical aspect of how these systems go together. So one of the things for every DE1, that's our entry level design engineer, they go out on a multitude of site visits. And so what they are doing is they're meeting with the contractors, they're seeing the systems installed, they're seeing how it goes together. And that, ultimately makes them a better engineer because right, they
Yeah,
understand how it works. And that's the part that's
yeah,
missing across HVC engineering that I see, that they design this thing on paper, but they have no understanding of how it actually goes together.
yep, yep. So no, that's great. And I know another engineering group that they're doing the same thing. They get the young engineers right out in the field. Here's a Takeo box, wire it up. Something isn't working right. Go figure it out. Go trace the energy from its source. Where is the bottleneck, so to speak? Where is something not working that is causing the system to do what it's doing? I
Right.
think is it just irreplaceable experience for
We go
engineers.
one step further because we're starting to see the intersection of building science and HVAC come together. But like system is a building, right? And everything kind of affects everything within the building. So I think we're the only engineer firm that I know of that does their own blower door calculations. We run our own blower door tests, right?
Nice.
We have true flows, so we can measure the airflow and air handler systems. We have manometers, Retrotech and TEC manometers that can measure static pressure in ductwork, so we can see where the weak points are. We have flow hoods, so we can measure the airflow coming out of registers to make sure we get proper balancing. We have a Keyence flow ultrasonic flow meter, so we can actually strap on a flow meter and see what kind of water flows we're getting in a pipe. And so, the data doesn't lie, and so you have to have these tools at your disposal to understand and diagnose the system that's, you're commissioning or making sure that it's working right. So, yeah, it's important.
Very good. Very good. So, Rich, put on your crystal ball or get out your crystal ball here. I've got one last question for you. So, again, we've been doing this for a long time, and we've watched a
You don't
lot
have
of.
to keep reminding me. You don't have to keep reminding me now.
Well, we look in the mirror and we remind ourselves, I guess. But
Go ahead.
yeah. So, anyway, where do you see the hydronics industry in North America 5 years from now?
I think we'll make gains. I think we've had a terrible time with the whole mini splitification of the industry. I think we'll have gains uh, over the next 5 years. I think I've just decided, we have the rep business. We've just decided to go back into the PEX game with Mr. PEX. Just because there's another generation of people to teach. And so I think that's going to be the future. I think all the stuff we've talked about. So I think it's going to be a good time over the next 5 years. I think as the air to water heat pump is going to be the driver, just as condensing boilers were a great driver back 30 years ago, and now 30 years ago. And they're fundamentally going away now as fossil fuel is almost mandated against, sadly. I think hydronics will grow now but we need that air to water component. We have to have it to be able to push hydronics.
Yeah.
It's actually a good, it's a heartening time, actually. Go ahead. I'm sorry.
It really is. To your point, I think this is, and again, looking at the years, this is really one of the best times I can think of to get involved with hydronics. Not just heat pumps, but with electrification in general, thermal storage, the ability to craft systems. A good example would be net zero construction. And Ross, you're talking about too, getting technicians to understand more than just the mechanical system, to understand the building dynamics that that mechanical system is working within. So it's a fantastic time to get involved with hydronics, and we're seeing people that initially dismissed hydronics kind of rediscover attributes in it, not just a heat source, but things like distribution efficiency, running a whole house on a 50-watt circulator and on a design day.
Yep.
Impossible to do that on the air side. So overall, a good time. So Justin, I know you've got some exciting information coming about a new product from Enertech, and we're going to give you some time here to go through that, and then we'll wrap it up at the end.
Yeah, we can make this pretty quick. We've talked a lot about air to water heat pumps. There's been a lot of questions. I've been kind of reading off to the side here. But we are offering a new option for our air to water heat pump. We're calling it EM Flex. So several people on here may know that with our current air to water, we have an indoor module that is a wonderful option. And from a functionality standpoint, it's really great for single family homes, and it does a wonderful job of working out all the intricacies of heating, cooling, and domestic hot water. Uh, because there have been a lot of questions coming from the field on maybe larger projects that require multiple outdoor units, or people that just want to do a single function, maybe just domestic hot water or something to that effect. We are releasing this product that we're showing on the screen here. We're referring to this as EM Flex. And essentially what this is the indoor control portion of our system that allows you to do whatever your job requires on the piping side. So although we do have an all-in-one box solution for heating, cooling, domestic hot water, this just kind of opens the door up to use our outdoor monoblock heat pump and essentially send that 40 to 140 degree water to whatever that load could be. So included in this is all the required electronics to get full functionality of the outdoor heat pump. You can see it's much smaller. Anyone has one of our current heat pumps. This is basically about the size of a shoebox and would fit on your wall. It does have integrated Wi-Fi connectivity and works along with our app called My Uplink. Someone asked earlier if we offered any sort of measured or logged COP. This absolutely does, and can graph out the history along with many other aspects of the heat pump system. It does have a touchscreen interface that you use to configure all the settings for the outdoor system. And this is coming with our dual fuel indoor wiring board. So it is capable of modulating an external boiler. This system is also capable of being cascaded. So there's quite a bit going on in here. But basically we're leaving it up to the installer on to fulfill their needs. Our full indoor module with either the electric backup or the dual fuel version would be my preferred choice just for ease of installation. If it's a single unit on a single family heating, cooling, domestic hot water operation, this opens it up to be installed in a lot of different configurations. So you can kind of see here what that field wiring board looks like. We have a modulating out, modulating in portions on the board, as well as a TT for whether you are going to hit a dual fuel setup with a gas boiler, or you could back it up with an electric boiler also, depending on the job. Uh, I did see some questions earlier. People were talking about outdoor temperature ranges. Our unit goes down to -13 degrees Fahrenheit or -25 Celsius for ambient temps, and then we offer backup options, so either electric or dual fuel. So here you can see the comparison between EM Flex and what we refer to as EME, which is the electric backup, or EMD, which is for dual fuel. You can see that we've integrated all the piping into the large format indoor module with motorized ball valves to direct water and have all the timing of that worked out, making sure we don't send chilled water or heated water to the wrong place at the wrong time. The EM Flex leaves all of that up to the installing contractor. So it's a much more cost-effective and smaller footprint option that could be mounted just about anywhere. You can mount as many of these together as you need, but it just opens up the flexibility of our monoblock air source heat or air to water heat pump. So these are the accessories that come along with it. We do have the same stainless steel flex tubes with insulation that comes as an install kit. Basically, that's for vibration isolation and on the outdoor unit. We do still require our variable speed UPM XL pump. This is a Grundfos pump that comes in an insulated cabinet, as well as we use these isolation double O-ring ball valves for either side of that pump. It still comes with a flow meter and then a couple wiring things that come along with the install kit, and a Y strainer because the outdoor unit is using a brace plate heat exchanger. All this comes with the system and really just kind of, like I said, opens the door to be able to install this in whatever configuration you'd like. I get a lot of questions to provide just solely domestic hot water heating systems, multi-unit applications. Here's a couple of example drawings. These are just kind of real brief overview. So the green box here just kind of simulates a load. It could be a swimming pool, it could be a building, could be a lot of things. And this is a direct to load piping configuration to be able to mount multiples of these heat pumps. I think you have another piping schematic here that shows with the hydraulic separation. Yeah, so a decoupled option here with the hydraulic separator. Certainly, this is something that could benefit multiple installs. We still do require the pump, one pump per heat pump, and unlike most of our competitors, we are measuring volume of flow. So we require the flow meter and the pump to be there, and those are controlled by that EM Flex indoor module. So we can open this up, and here's a drawing showing it with backup boiler integration. I don't want to get down the rabbit hole too much on some of these, but these are just a few application drawings that kind of shows the flexibility of what we're talking about. And like I said, the current indoor module is a great option for a single family home. This is a good option for multi-unit or a single function unit if we're just producing heating and cooling or whatever your application might be. So we are opening this up for orders currently, and we will start shipping this product in, I think, about 3 weeks, 2 to 3 weeks, somewhere in that range. Our product manager is out right at the moment, so I don't remember the exact date that we're going to be shipping, but it's very, very soon. So of course the outdoor unit is basically unchanged. The slide on the screen here, this is a graphing view showing some history of the log data coming from that air to water heat pump. I could spend hours talking about just this app and all of the functionality and features here. Just know that we're monitoring several hundred data points on a 3-second basis that gets uploaded to the cloud. Basically, any metric of energy monitoring to actual BTU output to COPs, compressor speeds, refrigerant pressures, temperatures. All these things can be logged remotely. And there is a homeowner version as well as a contractor version. Then this app is there is a web-based online version as well as an app that you can get on a mobile device. There is no cost associated with this app. So once the unit is up and running, you get that free with the equipment. And you could run to the next slide there, John. I don't remember how many slides you have here. There we go. We're on to Q&A. So
Before you jump to the next part, I was just going to mention, Justin, that uplink I think is an undersold aspect of your system, because as a contractor, they can log in from their computer to see the performance of the heat pump without actually having to drive anywhere.
Yep.
So if they get a phone call from the homeowner, they can take a look and see what's going on. So they could even maybe diagnose what's going on from afar, or even ordering the part if there's a part that needs to be ordered or whatever, before they even get to the job. So they have some insights going on. So this is, I think, a great undersold feature of your unit.
and this is two-way communication. You can make settings changes remotely. So if someone were to, mess with pump speeds, for example, and cause a comfort issue, a contractor can log in remotely from their phone or their computer and notice what the problem is, make the setting right there for the homeowner, and go about their day. This same app exists on our water-to-water variable speed product as well, with all the same functionality. And we have, for all of our geothermal heat pumps, we have this app available also. Although on the non-variable speed product, it's kind of, it doesn't have nearly as much data. So it's very useful, and you can still diagnose problems remotely. It's just that on the variable speed product, there's a full suite of sensors. And that's true on the air to water and on our water to water variable speed products.
Yeah.
Okay, so let's go back, Kevin. I know you and Justin have been monitoring questions. Fire away.
Yeah, we've got quite a few, but kind of in that transition, we'll start with a couple of this EM Flex related ones. Justin, someone asked if there's any performance differences that will be noticed when you're comparing the traditional EM indoor module compared to the Flex.
No, the performance of the heat pump is identical. It really just boils down to, the old indoor module or first indoor module was really just about dividing up that hydronic load side and sending it to the right location at the right time and making it easy to install. The EM Flex offers all the same capabilities. It's just not including all of the piping. So depending on what your install is, installers need to make the determination on what's best for their project. It really comes down to, can I do this with the full indoor module, and does that make more sense? Does it save me enough labor and material costs? Or does the EM Flex make more sense? It's really a job by job basis.
Someone asked if there was any competitors that have similar units, and how does this compare?
Argue that when it comes to air to water, right now, we're the only air to water monoblock system being made in North America. Most of them are imported, most of which are coming from Asia. Some are coming from Europe. Ours differs quite a bit from other products on the marketplace because we have things like built-in outdoor reset, integrated, indoor module that offers all of the flexibility to do a true 3-function system and install it easily and just hook the pipes up. At their core, a monoblock air to water heat pump makes heated or chilled water. It's what you do with that once it gets in the building that really kind of separates the features and benefits of these systems. With ours, having the app and the Wi-Fi connectivity, being able to change settings remotely. I've heard of some others claiming that they can do things like that. I haven't seen it in practice yet, but there's a lot of people that have prototype products that they're building for the air to water market that just aren't available yet. So I'm sure we'll see all sorts of innovation from other companies in the future. I'm happy that we got a head start. So, we've had our air to water out for a few years now and certainly learned a lot in that time frame, and trying to make it the best product it can be.
Awesome. We still got some rolling in, so I may come back to some about the EM Flex specifically, but I'm just gonna kind of go in order to some of these I had saved. So we have one, again, anyone that can answer this, just chime on in. It says, with all the concerns recently about climate change and raising temps, are we still seeing geothermal as the most efficient option? Or is there some point where geothermal might not even be an option anymore because of the environment?
Uh, I can answer this one. Geothermal, just because of physics, will always be the most efficient option. Uh, However, with that being said, geothermal is not always the most costly or cost-effective option. And depending on install challenges and location, the three guys that we have on here today are all in the Northeast. The cost to do geothermal out there is very different than where I live. And so, they're faced with a different set of challenges than other parts of the country. So it really comes down to location and what's the best thing for that job. Ross brought it up earlier that if budget was no option, he would like to not have any outdoor equipment. And again, like I said, geothermal will always be the most efficient. Any advancements that happen on the refrigeration side could be applied to geothermal. So as air source units become more efficient, so too will geothermal heat pumps. But I understand the challenges, and certainly that's a business that we're in. And although I am a geo guy, I do see the benefits of having air to water heat pumps and the benefits of hydronics. And I understand that geothermal is not applicable for every single home out there.
Another one that says, what has to be changed to make air to water heat pumps the preferred technology and not only a niche product in the overall residential market?
Product familiarity. I just did a count this week. There are 19 different companies that are offering air to water heat pumps now. So the availability of product is not a problem. I think I would certainly stress that, and we've seen this over the years, where a new technology is out there, be it a pellet boiler, solar collector, whatever it is, somebody gets very excited about the heat source, and they just assume they can cut it into an existing system that is designed or poorly designed in some cases, and everything's going to be fine. So that isn't going to be the case. So they have to understand the operating characteristics. A heat pump is not a boiler. It has specific temperature and flow requirements that need to be respected. They are broad enough that good hydronic designers can do a lot of different systems around them. They're not something that is highly constraining, but they are different from what you might have, for example, with a cast iron boiler. They also need to know, I call it the Hydronics 101. We see people jumping into a market that they're excited about a heat source, but they don't know how to size a pipe or to size a circulator or what hydraulic separation is. So they're trying to apply this high performance heat source, and they're doing it, they're just assuming whatever they connect it to is going to be fine. And I use the analogy, it's like if I went to Europe and bought a Ferrari Formula One racing engine, and I brought it back here and installed it in a Cub Cadet lawn tractor and took it to the next, NASCAR race. It's a ridiculous combination, and yet we see people doing this, taking high performance heat sources like air to water heat pumps or geothermal heat pumps, or for that matter, even mod con boilers, and putting them into systems that are, hacked up over the years. I mean, we've just seen these piping abominations, I'll call them. And I look at them and I could spend hours just trying to figure out what were these people thinking when they installed this piping. So learning the Hydronic 101 and respecting the performance requirements of the heat pump are paramount.
if you do that on the Cub Cadet, I want to drive.
Yeah, well, okay. We'll get that 10-cylinder Ferrari engine and that Cub Cadet somehow. Don't you guys have lawn tractor races out there, drag races out in the Midwest?
What's this you guys talk, John? Hey, what I will say is here in the Midwest, we know how to have fun. That's what I
Yeah.
want to say.
Yeah, we do it with tractors out here, I guess.
You got another one here. It says several major manufacturers are signaling intent to enter the U.S. market soon via trade shows and other. What might be driving this?
Power, water.
I think electrification movement. I think that's a big one. All the rebates and a lot of the structures there are pushing for electrification. So I think that they see air to water as that next frontier, and so that's I think a big part of it as well.
They want to be present. I'll give you an example. New York State, as of January 1, this coming January 1, any new construction under 7 stories, no fossil fuel of any type. Gas, oil, propane, even gas cook stoves. That's where the law stands right now. Other states are probably in similar timeframes as far as trying to, move fossil fuels out. If you want to play in a hydronics market, you've got to have something that doesn't run on fossil fuel. And I think air to water is a good logical choice. So
Yep. And competition is not a bad thing. It'll grow the market.
absolutely.
You think the price of doing air to water heat pumps will ever come down?
Competition usually does that, doesn't it?
Yes, it does. And I think we were discussing this right before we went live, and a lot of the inflated cost of air to water at the moment has a lot to do with contractor uncertainty. Contractors are rightfully nervous with new product, and I came from the contractor side, so I could fully understand that. But also just not having a good understanding. A lot of them, this is kind of their first go at doing chilled water. Let's say, you take these guys that are experienced boiler guys, and they've heard some of the horror stories of condensation issues and things like that, and so they don't really know how much labor they're going to use up insulating pipes and doing all these things. They just don't have what time in doing it. And so they inflate the cost up front. And the unfortunate part about that is that it makes it hard to adopt new technology because you scare people away with the price. And in my opinion, no matter what you do, education is never free. These guys are looking for people to pay for their skilled labor and education for them. And no matter whether you learn the school of hard knocks or you pay up front to go to school, you will always pay to get an education one way or another. And I wish that, more contractors would come to training, come to webinars like this, talk to guys like Rich and Ross and John. And if you don't have the answers, reach out to someone that does, instead of having a bad experience that ended up being costly to the contractor as well as the homeowner, and potentially end up with an abandoned system and everybody's pissed off about it, when a lot of that could have been avoided with, some upfront education.
Yeah, 100%. I think contractor training and comfort level, making sure that they understand they're comfortable with the products, is so critical here. You know what I mean? Because if they're not familiar with the products and they've never been trained on the products and never installed the products, of course the proposals and the bids are going to come in high.
Yep.
So we just saw that on a project where they were quoting a mini split system for, let's say, $30K roughly, and then they were quoting a air to water equivalent system in their minds as like $55K. It's like almost double the cost. And I can tell you that there's no way it's double the cost, but it's just because they have no familiarity with it. They have never been trained on it. They don't know it. So of course they're going to mark it up. They're going to be
Fear factor pricing. Yep.
I think part of it too is reaching beyond just our contractors and reps and wholesalers. I've been dealing a lot with some of the state energy offices, some of the people that set these rebate programs, and I've come to the conclusion these are really smart people, and they have very good intentions, but they don't understand hydronics to begin with. They still have this antiquated view of what a hydronic system is. They don't see the potential there for things like integrating hydronics with time of use rates and heat pumps, thermal storage, and even builders. Builders, utility people, getting utility people to understand. Yes, there is a heat pump solution for hydronically heated buildings. So just awareness that the product exists, or at least the product, the concept exists. And as I say, there's plenty of suppliers on the market right now to provide that product.
Yep.
When, if ever, can a heat pump supply existing hot water radiators previously using a fossil fuel system?
And pretty much every case,
Yeah.
this is something that comes up all the time. People get real concerned that the air to water or water to water heat pumps cannot output, 180-degree water or even 160. We're really temperature limited based off the refrigerant and oil use that's used in these systems. But the reality is, even in the Northeast, I've traveled all over North America, been involved in literally thousands of systems. I can count on one hand how many times the home actually required 180-degree water. Just
Absolutely.
because the previous boiler was set at 180 doesn't mean it needed 180. Uh, and in most cases, we're talking about older jobs, older homes. There's been efficiency updates to the structure itself. People have replaced windows, doors, or re-insulated attics, all these kinds of things, which lets lowered the BTU requirement per square foot. But I feel like one of the big parts that people miss here is that a lot of these people, the motivation for going from a legacy boiler system to an air to water heat pump is to add cooling. And when you add cooling, you get the addition of either a wall mounted or a ducted hydronic air handler that can also provide heating. So you've increased your heating output capability, which will then lower the deliverable water temperature that's required for that home. Uh, and so there's so many design elements here, but so many people, and this kind of speaks to why we haven't seen wider adoption of this product at this point in time, is because people just automatically dismiss it because the water temp isn't 180 and the boiler that's in the basement set on 180, whether it needed it or not, is kind of irrelevant. People just dismiss it and say, well, I need 180 degrees and I can't do it without that.
Right. Yeah, to piggyback on that, Justin, a lot of times, right, the gold standard is to run a manual J, right, an ACM approved manual J load calculation to figure out the heating and cooling load of that building, whether it's a retrofit or new construction. And what we're seeing and what we're hearing and what we're finding is that the manual J inflates the loads. And so the reality is that the heat loss of the building is not as high as what the model says it is. So what ends up being what you think needs a 5-ton heat pump might actually not need a 5-ton heat pump on design day. It might need something of far less, or in a bigger house, instead of 8 tons of heat pump, it actually needs 5. And so we're starting to see that when you actually run the data in terms of energy use on these boilers or on the traditional systems that are in these houses, the loads are actually inflated from the modeling perspective. And so that's, I think, I've heard that ACA is going through, they're on version 8 right now. They're going to be updating to version 9. We'll see when that gets released. But the talk is about having that be a little bit more accurate with the load calculation methodology.
Yeah. I can tell you about a simulation we ran up in Plattsburgh, New York, way up in the northern tip of New York State. That's an 8,000 degree day climate. It's a design temperature of -9 Fahrenheit. And we looked at a nominal 4-ton heat pump. And keep in mind, many of you know this, but when we say a 4-ton heat pump, 48,000 BTUs, that's a nominal rating. That could be a 5-ton machine under certain conditions. It could be a 2-ton machine under other more constraining conditions. So we've got a highly variable output, but the simulation takes all that into account. And we found that a house with a nominal 36,000 BTU design load in Plattsburgh, New York, with a nominal 4-ton heat pump, that was covering about 95% of that space heating energy. And it was with baseboard. And at design load, the baseboard was 170-degree water temperature, but we were using outdoor reset in the simulation. So under the vast majority of those heating hours where we're running at much warmer outdoor temperatures, we can run that baseboard system at 120, 110, well within the operating range. And this was a 410A heat pump, not an R32 or 454B heat pump. So we're finding, actually quite good results. I think encouraging results of operating a heat pump in a cold climate with an existing heating system. A key being outdoor reset. And another thing I should throw in here, if it's cast iron radiators, or even if it's old system with some steel or iron piping in it, before you push fluid through that heat pump, flush that system out good. Use Fernox, or there's other products, but Fernox makes a product that will go through, and I call it a hydronic detergent. You're going to clean the system out. We don't want to take iron oxide or magnetite. We don't flush that into the heat pump, or for that matter, if we're putting in some ECM circulators, we don't want to see that those circulators clogged up with that magnetite. So flush the system out good before you commission that heat pump.
Yeah,
One
just keep in
more.
mind,
Oh,
if you're
sorry, Russ.
go ahead.
No, you're good. Go ahead, Russ.
If you look at your thermostat and you know that you have a properly sized system, on design day, that system should never shut off. It should run 100% of the time for the entire 24 hours. That happens on design day. If it truly was a design day, it should never shut off. And when you look at it, let's say an Ecobee thermostat, and you look at the cycle rate of these units, you see it short cycling, even on a 10-degree day or 0-degree day, or whatever the design, load day is for that climate or for that house. It short cycles. So you know that the system's oversized. You go a step further and you can measure the electrical with Emporia View and some of these other products. You can actually measure the electrical load of when those units kick on. So you can actually quantify it to see how much oversized it is. So I think what we're learning is that these heat pumps can actually be downsized compared to what the models and the manual J's are telling us. And that's going to reduce the install cost, reduce the pipe sizing, increase the efficiency of the system, and provide better heating, better comfort, better cooling. So it's a win-win-win.
I'd like to remind everybody that the high science that happened back when the baseboard system was installed was the installer measured the exact length of the entire outside walls and put it up. That was the science. Just to remind you that, and so every one of these buildings has been further insulated, tight. So to Ross's point, that they even on the coldest day, those systems would pulse like crazy. So Justin, to your point, I don't think there is a system that cannot have modulated water temperature going no higher than 130, 140 that wouldn't be perfectly comfortable, because you would then keep up with the heat loss versus trying to catch up with the heat loss, which is what we try to do with high temperature systems.
Yep.
And radiator systems were designed for coal-fired systems, which was 150 and 160 degree water temperature back then. And those buildings also have been insulated.
All right. Thank
Cool.
you, guys. John, can you give us a sneak peek into next month?
Sure. Yeah, we're going to move over to Earth Couple or Earth Source heat pumps, talking about those next month, and specifically a project that we're involved in where we did a no joint or no fusion joint approach to ground loops. It involves kind of a unique method for getting the pipes through a concrete wall. This is new construction, internal manifolding of 4 individual earth loops, and kind of a unique approach. Ideally, when you're doing an earth loop, you've got a nice straight trench. You're going out and you're coming back, and you can pretty much count every circuit's going to be almost the same length. But think about this. If you've got a 6-foot wide earth loop trench and you're going around curves in your trenching because you've got trees or other underground utilities you have to avoid, the pipes on the outside of the trench are longer than the pipes on the inside radius of the trench. So how do you deal with that? And so we put this webinar together to show you several kind of unique details on an earth loop approach that doesn't involve fusion joints, puts almost 4,000 feet of HDPE pipe in the ground. And that'll be coming up on November 20th. So put that on your calendar.
All right, thanks, John. And that's going to do it for us today. Special thanks to Rich, Ross, and Justin for all joining us today. John and I are always here. Thank you for all you guys listening in and submitting questions. We really appreciate it. Don't forget to sit tight for just a moment to fill out the survey if you could. You'll be receiving an email in the coming days with the Q&As, presentation slides, copy of the video, and a link to join the next month's webinar. We hope this is beneficial for you guys and that you'll join us again next month. Have a great rest of your day.
Thanks, guys.
Yep,
Yeah,
thank you, guys.
Thank you.